Hello, this is the second of these two Ferguson 3V22 video stars that I picked up just lately. I'll plug this one in and see what happens. It's a bit unusual, this one, like it looks like it's got a different cover on it. They're normally black, the 3V22s. This is a different lid to the other one. It's got this, on the other one, the metal trim goes right over the edge, where on this it's got plastic sides and then that's in the middle. It doesn't say Ferguson on it, so it's like it's had new parts or something. Oh well, I'll turn it on anyway. That light's come on and I can hear a motor running. See if it'll eject. Yeah, it ejects. That head drum's spinning in there. Just throw its keys out. That play key's slow at coming back up. Look at that. Could be some switch that's bent or damaged or dirty. I have to open it up and have a look. Now straight away I can see differences from that other one. It looks like it's got the later version of the mechanism with this. You can see this plastic impedance roller. On the earlier one, that's made out of metal, and the way it's mounted a bit different as well. This foam on the side of here is just crumbling. I reckon if we have a look underneath, we'll find that it's not got that big long belt and it's got an idler instead. Someone's had this cassette compartment out and not put all the screws back in. You see there. Yeah, it says I thought it would be. Look, there's that idler. Oh, look, like this is changed. On the old one, you've got a belt running along here, and running this and that. Sort of the edge of the belt goes there. It's a different type of clutch, and it goes round here. That's not there. That's not there. A bit of grease on there. Looks like someone's been in and greased everything. Put loads of grease on it at some point. The grease has kind of gone a bit sticky. You know, someone's obviously been having a crack at it. Now if you look under here, you can see this motor's running, Capstone motor. But what's actually happening is this belt's slipping. That should be turning, but it's not. So I'll see what happens if I operate it by hand. So it's turning that way. I think it's just loading and unloading. I think this mechanism might be out of time as well. Look at these loading arms. Right, it comes to rest there. So that don't go that way. That's not going that way, it's moved back now, I've pushed it. That sits there. And it's just not moving, it's not synchronised. Like that moves back and then that's miles behind it. And it does that. So I think the mechanism's gone out of time. Now on closer inspection of this, I think what's actually happening is because someone's put loads of grease on absolutely everything in the deck, and that grease has gone gummy. I think things are just not moving very well like that. it's hard to move that because there's this dried on grease that's gone all sticky, and I think it's that. I don't think the mechanism's actually misaligned or out. What I'll do is put some tape over this end sensor and see if I can get it to load up. I'll try loading it, and I'll just help these things to move when they need to and see how it works. They're both returned properly now. I think they just need cleaning, and I'm not sure whether they're supposed to have grease on them or not, because there's just grease on everything. That obviously doesn't solve the problem of the motor running constantly. I'll see if I can get it to load and go into play and stay in play by putting some tape over the supply sensor. If it'll play properly, then the mechanism's probably fine. I put tape over that supply sensor. I'll switch it on, press play. It's not going key yet. It has done now because it thinks it's not running. It's not key out now, but it has loaded up. I think it were playing, but it's just got the belts are so slack. There's no take up. Yeah. If I rotate that take up clutch, that's rotating properly. And it seems to be alright. Pressing stop and disengaged it properly before I trigger stop solenoid by clicking it off. Then it does, and it unloads. Now, this is part of the motor control circuit. The motor control signal from the mechanism control chip comes in here, and it's inverted by this NAND gate, so why there's an inverter. From there it goes to this transistor. So if that's high, the output of that NAND gate, then that'll turn on this transistor, which will cause this point to be low, which will reverse bias that diode. The base of this transistor will be pulled low by this resistor. The emitter of that is going to the base of this transistor over here, which drives the Capstone motor. So motor will be off. If it's low, this will be off, which will allow this op amp to control the motor through the diode, because the diode can be forward biased then. So this circuit is what I'm going to look at. This is on servo board, so I'll start by looking at the motor control. So I'll follow the motor control signal through and see what's happening. So I think it'll either be that the motor control signal is wrong, or this chip's faulty, because after that chip, the drum and capstan motor drive circuits become separate, because this bottom one that I've followed through is for the capstan. That same signal goes to this transistor and this transistor and this transistor over here. That's a similar circuit for the drum motor. So because they're both running, I would imagine that it's part of the circuit that is common to both. So it'll be prior to here, this chip or the mechanism control chip, I think, or the inputs to the mechanism control chip. Just looking at this chip, it looks like someone's actually replaced it at some point. Well, this brown flux residue and the look of the soldering, it looks like it's been done by hand rather than like the soldering from the other chips. There's a couple of other things that look like they've been done as well. IC5 and IC2. And someone's definitely had a go at this machine. But you'd think if they replaced IC3, unless it's failed again, well, we'll find out if it's failed. They might have replaced all this, and it might actually be something else. Right, I'll have a look at that IC3. It's got 12 volts going to it. That's the power. the input, oh, that's at 12 by 11.3 volts, and the output is low, so that seems to be working right. See, that should be, the input should be low in stop mode, which it should be in stop mode. So if I press play, that stop solenoid fires. Let's have a look at other gates on chip. This is another one, they're both low. Okay. Low, low, that seems to be low as well. That gate seems to not be working. Another gate. I don't think I'm getting a proper connection there. That's I. Some in between non-valid amount. There are two inputs to other one. And output. Are these, am I just getting averages or some change in signal here? Right, we'll have a look at it on scope. This is input to the gate that we're looking at for motor drive. The inputs. That's the output, which is low. That's right. Other gate, low, low. Lowish, not a proper amount. Another gate, I, invalid level, invalid, invalid, invalid. What's going on here then? What are they connected to? And so there's only two gates in use, and according to this, pin 12 and 13 should be low, but they might have just tied them high instead, because they should, according to this, they're just connected straight to earth, but they might have decided to connect them to 12 volt rail instead. What are these ones connected to? Capstone head. And that's being used as, they're being used as an amplifier for Capstone pickup head, which that won't be getting anything because it's not spinning. Right, it doesn't seem right, that, I don't think. That gate where you've got low, low, and then that. I think I will replace that, because it's easy enough, because it doesn't look right to me, that. Even though the gate that's responsible for the motor drive does appear to be working properly, just them other things are putting me about a bit. I don't seem to have any 401 ones, which I'm surprised about. I thought I did have some, unless I misplaced them somewhere. But looking at how they're being used in circuit, they're not actually being used as a NAND function. One's just being used as an inverter, and other one's wired up with some negative feedback and being used as like an inverting amplifier. So I think I should be able to get away with using a 4001 NOR gate chip. It's got the same pin out, so I think it should be alright. I've got this chip tester, and I'll put that NAND gate chip in it. It's saying not found, so it's obviously faulty, that chip. So I'll put this a quad NOR gate rather than a NAND, but it should work. I'll try it. The motor's still running. The inputs, that's the input from the mechanism control. That's the output of that thing, so that's right. And this gate, low inputs, aye, that's alright now. And low, aye. And then this is that gate that's wired as like an inverting amplifier for control track pulse. Not the control track, the Capstone flywheel pulse. So we'll have to look at the mechanism control chip. Right, well, this is a internal logic diagram of the Mechacon IC. I've written down the levels at the different pins that there should be based on checking a working machine. So this is in stop mode with no taping. These are the levels that you should get. I'll use this to test the one in this machine, and then if these are all correct and the motor control output is on, then it looks like it's the Mechacon chip that's faulty, and then I'll have to either see if I can get hold of one, a replacement, or I could possibly make a replacement in using logic chips like CMOS logic, which I think that's basically how the previous model were done anyway. I'd have to see whether I can get it to fit anywhere in the machine. Right, I'll start testing motor control output. It is high, which I knew anyway. After load switch input, this should be low, and it is. Record select, that's low, yep. Camera pause should be low, 1, 2, yep. Record in should be high, yeah. Pause in high, yep. Unload switch in should be low. It's high, it could be that. Take up sensor, I've got that down as 7 volts, and it's 5.93 FF in that. That's drum flip flop. It should be a flat line. I mean, on scope, it should be a flat line if drum's not spinning. In this case, it should have the flip flop signal there because drum is spinning. But I'm only measuring it with this anyway, so you won't be able to see it. Play in should be low, and it is. Rewind in should be low, and it is. End sensor should be high, and it is. Start sensor should be high, and it is. Search in should be low, and it is. Tape guard should be high, and it is. Operating should be low, and it is. Resetting should be low, and that is. So unload. So if we look at the logic, the unload signal, if that's high, that goes to this NOR gate, so that output of that NOR gate will be low. It goes to inverter, which brings it high, which is that motor control signal. So we need to look at that unload switch. This is the unloading switch. It's a bit difficult to see because there's these wires in the way, but there's like 2 sort of leaf spring type things, and they're actuated by this. Motor's stopped. So that's not getting pressed in properly. I can see it's a bit bent, and if I slide this back you can see that this top one is a bit bent, it doesn't line up with the other one. When this pushes that way, that's already bent a bit, so it's not pushing it right in. So hopefully if I just straighten that out, then that should solve that problem, and then we can see, put some new belts on and see how it plays. Wires are in my way. That should be alright, I think. Right, put some new belts on and we'll see what sort of picture it gives. That belt's not actually too bad, but might as well change them all. That one is tighter. See, this belt kit doesn't have this belt in it, because it's the belt kit for the mechanism with the big belt. So it's got this one which you don't need, and then you have to supply your own one for this, but I'll be able to find one. I've got this one here. It's not quite as thick as the original one, but it's about like a 1mm one. I think the other one looks like a 2mm cross section, but it should be alright, I think. Head belt. Let's have a look. Oh, it's a bit dirty. There's this little, these little brushes there that earth this to get rid of static build up from spinning head. But if they get dirty, you start getting like white dots on screen. I'll just get a bit of a clean. when you put these back on, make sure that it lines up with this flat, the grub screw, and that it's fully down. And tighten it on quite strongly, because they have a tendency to slip down the shaft, and then it causes the machine to stop, because it thinks head's not spinning. There's grease everywhere. On top of the Capstone shaft. Like, why? Why have you lubricated shaft that the belt was on? Right, now changed belts, we can give mechanism a try. I've taped down the cassette detect switch and put a bit of tape over it, photo sensor, the supply one. So press play. It's not starting up. But it's all this dried on grease that's on everything. And I think I'm going to have to clean some of this off. One thing I did notice is the oil fence that was over at Capstone's disappeared, so they obviously lost that. Got it all open and put loads of grease on everything. See, that's not moving across properly, just tons of dried on grease. I should be coming across and engaging with that cog on flywheel. There's so much of this dried on grease on everything. I'll get it clean. Try it again. I think that thing's come undone, but it is at least loading now. You see that is like a bit bent there. You sort of see it moves a bit funny. This cassette lamp holder's a bit dodgy as well. Like this clip on here, the one from that side's missing. I'll have to see if I can repair that. I've done it before because they do break them. Like the older style one that like screws down is better. This one just it's held in place with them clips, but they break, you know. It doesn't stand up straight then, it's like bending over. This is the other bit that's causing problems. This, how it comes across. It moves across sort of alright, but then when I press stop, it don't return. You don't get out of the way for that guide pole to come past. It's still not fully returned. I'm going to clean this bit where this impedance roller arm moves across now. So I press play, let it move across, and just switch it off, and that allows me to get in here. See how it moves now. We'll have to take this top off and take the whole thing out. I think what I'm going to have to do is, so I can get this back area here properly, take this off and then try and clean that. Can't really see it, but you'll be able to see it once I take the back off. There's a plate that moves across, and then try and sort of move it to one position, move it to other, and clean round it with alcohol. Get rid of that hardened grease. Now, this is what I'm talking about round here. It's still a bit difficult to see because of this in way, but you can see this come out. This is part of the thing that slides across, and there's all hardened grease under there, so that needs cleaning out. Now, see what the loading's like now. That's moving across better. Not sure about that. This guide, as it comes into here, seems like it's not getting far enough and it's being pushed in by that. I'll try it with tape. Yeah. Does that catch him as it comes out? Right, you can see here what happens when it loads. This moves. I think that thing might come up. That comes that way, which rotates this. This comes this way, and that comes that way. And it's this one controls the right hand guide, like the take up side one, because it sort of loops round the drum like that, and that one goes round there. So it's this one. I'm not sure. It seems to be moving, but there's more dried up grease on this as well. I can see some on here, but I could certainly clean grease from under there and from round here. I'm going to try it with toothbrush first. See if I can do it without having to take the mechanism apart. It'll be a lot easier if I can. I'll try it again. Not sure if it's seeing any better. Try it with tape. It's like getting stuck there. This is loading mechanism again with cover taken off. I'll load it. This slides across to this sort of corner and then it sort of stays more or less there, but that slipped a little bit then, and it's in position. So I wonder, see, this is again, this has got all like that hardened grease on it, so it might be that. I'll try getting it clean. The only other thing I can think of is this looks like it might be slightly bent, but it's hard to tell. I can't really get my head in there and well enough to see it properly. Not really sure. I've put tape in. Might not have made any difference at all. No, it's not done. I've been examining this loading mechanism in a bit more detail and comparing it to one that's working properly, and I think I'm getting to the bottom of it. So this is, I've partially loaded the mechanism and it's got to a point where this supply side arm has gone into that V-block notch, and this one should have done. They're supposed to go in at the same time, and then these come across, these stoppers, these arms, to hold it in place. But this one, it's got some movement in it. I mean, that's supposed to move, this bit, but that one's got no movement at all. Well, I mean, I can pull it back because there's a spring, but I can't. I shouldn't be able to move that. It should be sort of fully up against this V-block. Now what this is, this loading arm comes round here, and then there's a pin poking down through that slot that's connected to an adjustable link on the sort of rotary part that drives them both, and that's moving. Like if I push that a little bit further, like a millimetre, then that's fully up against there. Now this peg could be loose, maybe. And I don't think it is loose, because if I push that up against there, then I can't move it. I'm like wiggling that peg from underneath, or trying to, and it don't move. So I think that peg's secure. So then if we go to the bottom of the deck, now this is where that peg's attached to this adjustable link to the rotary part. And that's got some movement. Now that needs to be sort of loose at that end, and this needs to be loose at this end, so that they can rotate on the spindles that they're on. That don't move, and it's fully up. It's like at the end of it, it won't go any further. So, like if I were to shorten this link just by about, well, that much, then I think that it'd bring it, you know, it'd bring it into V block at the same time as other one. But I'm not sure though, because these don't look to have been tampered with. Like that paint's still in place on it, on here, on this screw and on that. It looks like it's in its original place as far as I can see. So I don't know whether, I don't know, perhaps it has slipped minutely over time. In order to determine what state this loading arm's in, you need to remove the lower drum. Easiest way I think is to disconnect this board, like the preamp board, and to unscrew the entire drum, like the entire lower drum assembly, which includes these V blocks and everything, and lift it out in one, that and the board all in one piece. Alright, so to get this lower drum off, you got to remove this drum flywheel. Take that belt off. And back on top side at deck, you need to remove these plugs. This is a supply arm here. It doesn't look like it's bent, I can't, difficult to tell still. You have to bend, you have to sort of bend along its flat bit, like that way, in order to thingy. It should hit that, I think, and that, because that's what it does on this side. This post here, and it drives it up against that post, and then it's locked in place. Where on this side it's not doing, it doesn't quite reach it. If I move that adjustable link so that that ends up at that V block, at that post there, then I think that should cure it. I'll put this lower drum back in, put all that wiring back together, and that all the, and I'll adjust it. Even though it doesn't look like it has been adjusted, I should be able to put it back if that's wrong, because I'll be able to tell from the paint where it should go. I've loaded that up so we're there. I I think if I slacken it off and then tighten it up again with that held in place, then hopefully that should be alright. Still got a bit of movement, I think. Yeah. I think that's it now. Yeah. Right, so that's up against that V block now. So I'll try and load it again. Right. That's located into that V block properly now. It's solid. I'll try it with a taping. That seemed to load better. I'm going to see if I can rebuild this a little bit to make it stand up straight. It's not coming out very easily from this side, and I don't want to break what's left of it, so I'll turn it over and try and squeeze it out from the other side. This is where it pokes through the deck. So you can see there's a clip on this side, the other sides, one on the other side's come off. It looks like someone's tried to repair it, or, well, I don't know, it looks a bit melted, like someone's got it with a soldering iron or something. But I'll see if I can find something that I can glue to it to make another clip on the other side. I've got this like little PCB sort of mounting thing, and hopefully if I cut the end off, cut this bit off, and then leave it with just one side of this bit, then hopefully like that V-shaped bit, hopefully that might be able to glue that to it, and hopefully that'll work. I ended up doing it slightly differently from how I said, but So I've used the full length of that and stuck it to the side so it's got more area for glue to stick, for it to mate to it. I filed both, like the edge of this and the edge of that, to get a good surface to stick to, and it seems to be holding on properly, so I'll see if it'll fit in the thing. There we are, that's it in. That's nice and sturdy, that now. Might have a job getting it out when it comes time to change bulb. But another thing that I'm going to have to try and make is cover for this oil fence, so you can, as you put oil in there but you don't want it working its way up, so you put a cover over it. What I've got is some of these little things, these little screw covers. I'm thinking if I can drill an hole in the centre of that, so it's just big enough to go over that, so I have to sort of force it on, then hopefully that might work. Alright, well I made something. I don't think all's quite dead centred, but hopefully it should be alright. It's tight fitting. Hopefully that'll be alright. Yeah. I'll just see how it goes. Alright, just clean the take path. This is a better way of cleaning heads. Get a piece of paper and just hold it against the thing and rotate. Just about finished with this machine now mechanically, and I can move on to electrical side of it and try a tape. But there's just one more thing. Hear that noise? That's that. So just put a drop of oil down it. Right, I'll press play, see how long it takes to lock up, see what picture's like. It locked up quite quick. Picture's okay, apart from there's kind of a thing across here a bit, a line, but might just be tape. Bit unstable though. Keeps sort of jumping vertically. Yeah, if I misjudge tracking, it starts jumping loads. That's about optimum tracking. It's still jumping every so often. So that could be head switching point. I can check that because I've got a tape that's got head switching point like on the screen. So I'll play that and see how that plays. Right, it's taking a bit longer for the servo to lock up now. I'm not too sure really. Kinda looks okay. It's supposed to be on this line. If I start getting a lot of noise, if I misadjust it, no, see, I don't know. All this here, that shouldn't really be there, all them lines. So maybe it does want adjusting. I'm gonna have a look at FM envelope. I think someone's been at this. This is it all the way to one side. I have to put it all the way to one side to get this one to be sort of alright, but then this adds output's all funny. See, I can kind of get it's very difficult to set it properly. Well, you can't really. So I think the entry guide's been played with. That seems to be the point where you get like the maximum envelope. I think entry guide's been adjusted. So I'll slacken off locking nut and I'll adjust it. Because it wouldn't surprise me if they have been adjusted, because everything else has been messed about with. Right. That's maximum output, I think, yeah. And that's in more or less centre position as well. So if I and that looks better. I can keep going further, but then it starts to go like that. That's one way, and that's all way. I'll move on to looking at the head switching point. Right, so this is the head switching point. It's how far, this is the sync. So it's 1, 2, 2.5, 3.5, 4.5, 5.5, 6.5, 7. 7 lines before on that side. 1, 2.5, 3, 4, 5, 6.5, nearly 7. Is it? 1, 2, 3, 4, 5, 6, and like 6.5. 6.5 on one side and 7 on the other. So that one could maybe do with adjusting, but I think the problem of it jumping seems to have been solved by resetting that guide roller, so I think it should be alright. I mean, they definitely have been twiddled, these adjustments, because they have this sort of glue in holes, and that's gone, so you can tell that it's been adjusted. So I'll just adjust it back to make it the same as the other one. If Servo settles down. Yeah, that servo's going mad now. I'll need setting up. I'll just stop it and sometimes it settles down straight away, and then other times it just won't settle at all. Alright, so I'll just give this a tweak. That's 1, 2, 2.5, 3.5, 4.5, 5.5, 6.5. Another one's 1, 2, 3, 4, 5, 6.5. Look at Servo next. Right, I've got the capacitor C33. I've just been testing it and getting some funny results. See if it does it now. That's going on for a long time. No damaged part. It's at 38 microfarad. It's a 10 microfarad cab. And it's sometimes get a reasonable reading, sometimes it's get 11 microfarads, which looks right. I'm trying a different slot, see if that makes any difference. At 28.68. It's a big farad now. I'm going to replace that capacitor. Use this electrolytic, see what readings I get for that. Because I don't think, I thought it was the thing at first, and that's right. I thought it would test of just being weird. But it's getting consistent readings for this one. So I'm going to put this one in and then have a look at that servo. Right, I'm going to start off by setting the discriminator, the drum servo discriminator. There's a couple of different ways you can do this on this machine. I did one way with the other one that I did, so I'm going to do the other way with this one. So what you have to do is you have the machine unplugged and you connect 2 volts DC to test point 15, you know, between that and where you can use test point 13, and then you connect a multimeter to test point 14 and 16 on volts, well millivolts. You connect it across them and you run the motor. You might need a little nudge to get it started. And what you have to do is stop it and set it. It must be set to 10.2 when it's stopped. I think that's right, pretty much. I think You have to do it a few times to see what highest reading you can get is, and set it at that at 10.2 at that point. Right, I've got drum sampling position now. What I'm doing is the same as what I did on the other video. Put it in record, trigger from the video signal, and scope test point 9. And what you're aiming for is this point here. You slow drum down so it comes to here, and it should travel along, come back down and across that way by an equal length, back up and stick to there again. Went too far with that, I think. Right, now that I've set them up, let's see how quickly it locks up from a standing start. Not very good that time. I've done it a few times and it's been fine. Let's try it again. Might have just been a dodgy. Yeah, that's alright, that's pretty good. Right, I think we've still got servo problems, but it's the Capstone servo this time. So press play. I didn't do it that time. That's what it's doing. So I'll have a look at Capstone sampling position. Right, this is the Capstone sampling position. It's test point 11, and the top flat bit of that waveform should be about 75 milliseconds. We'll go on 20 milliseconds per division, and it's what, 2, 4, 6, 8, 10, 12, 14, 16. So it's 160, so it's more than twice what it should be. So adjust it. What is that now? 2, 4, 6, 8, 10. 2, 4, 6, 8. So it's 10 milliseconds per division. 2, 4, 10, 20, 30, 40, 50, 60, 70. That's what it wants to be at. So hopefully now it should be fine and locking all the time. I mean, I'm surprised it was still locking in alright most of the time. It was just now and again it'd start doing that twitching. It seemed to be doing it mostly after like doing rewind or fast forward and then going into play. So I'll try that. Fast forward it a bit and then I'll start it playing and see whether it locks up properly or not, and then I'll try it from the standing start as well and see how quickly it locks up. Hopefully it won't do that twitching thing. That locked up more or less straight away. Try it from rewind. If that makes any difference or not, I don't know. That's fine. I'll try it from a standing start. A bit of noise at first, but it's locked up. Well, it seems to be alright. I'll have to see how it goes on, because like I said, that we were doing it before, we were only doing it sometimes, but it's set up how it says in service manual now, so hopefully that'll be alright. You might notice by the way these lines on here, it needs the screen setting sorting out. So I replaced line output transformer in it a while ago, and I thought I'd set it, but I couldn't see them lines at the time, but it just needs a little tweak, turn it down a bit. Just done it now. I stop filming and it does it. See if it'll do it again. See, it's doing it. Alright, have a look at this servo circuit, see what it's doing. This is pin 16 of IC4, which this should be high to make it speed up and low to make it slow down. If I press play. It should be about 6 volts ish. Or 5.5. I mean that's about right. It varies, you know, depending on type, but it wants to be around sort of between 5 and 6 volts. You see, it were down at 4 and stuff, so it were going too slow. But the servo is doing something, you know. But it's obviously thinks that the motor's going too fast and it's trying to slow it down. Now this is the amplified pulse from the Capstone pickup head. It's test point 12. So watch what happens if I stop it and start it again. I'll start it up. Right, it's not done it that time. Oh, there we are, look. All this stuff here. And that's where it's locked up now. So I think it's all that lot it's detecting as extra pulses, all that noise. So I don't know if that's coming from the input to the amplifier or if it's the amplifier itself that's causing it. There's not a lot to it, this circuit, for generating these pulses. There's just this Capstone pickup head, which we saw under there, a capacitor, it's like a coupling capacitor C34, and the resistor, and then it's just this NAND gate with a feedback resistor and capacitor. So it's got to be one of them components, surely. I mean, it's hard to tell what's going on sometimes with these sort of closed loop type systems. Whether something else is influencing it, you know, something within the loops causing some strange behaviour that's ending up back here. But so I've already replaced that, so presumably it's not that. So it could be that, but it could be this if the replacement's not very good. But I wouldn't have thought so, because it seemed alright, but maybe it doesn't work very well as a like a linear amplifier. We could have a look at this capacitor. And this is that capacitor. .9 ESR, V-loss 0.7. Seems alright. It's a 1 microfarad capacitor, 50 volts. We've got a new one here. There's no sign of like leaking or anything on that capacitor. This is a new one. Not like a very high quality one, alright. 3.6 ohms. 0.3%. We'll try it. I don't think it is this though, but might be that chip. Well, it doesn't seem to be doing it now. It did it a little bit then. I've just tried starting it up a few times then, and it started fine without any problems, and weren't doing them big pulses all over the place. But I don't know, I'm not convinced that it's that's cured it. And that picture's pretty good. There's a little bit of inversion going on. You can see it a bit around here. Around here. Camera's not picking it up very well in that corner. Ah, you can see it. So that suggests that either one of the limiters isn't quite adjusted properly, or the FM level's like a bit too high. I'll try adjusting the limiter balance 1 and get it worse. And that's about the minimum I can get it to. And I'll have a look at the other limiter. This is output at second limiter and demodulator, and that looks pretty much perfect. Got these nice like bright lines at top and bottom. So I mean, there's either head adjustments or just FM level. So I'll just try adjusting FM level and see. I don't think it'll need much. I'll just get FM level a slight tweak. That's pretty much got rid of it. I don't know what's happening with that servo. It's going a bit mad. Maybe just a bad bit of tape. I'll double check it with this alignment tape. Not very good. So I'll just adjust that limiter balance again. It did seem like it were quite far one way. I think about there seems a place to have it. Try it with that other tape again. Yeah, seems alright. Yeah, that looks fine. think that's that. One thing that I did notice with this, it's not doing it now, but it were doing, is the switch to switch it between the aerial input or the camera input for recording didn't work properly. It just sort of stay in whichever one it were. I can't remember if it was stuck in camera, or you'd have to like wiggle the switch a bit to get it to work. So I mean, it's not doing it now. I probably cleared it a little bit by wiggling it, but I'll see if I can take it apart and clean it. It's this one here. What happens if I take this screw out? I have to take this board out first. It's still held in somewhere. Well, it's loose now. I think this like tuner board has to come out first. That's it there. I don't think that can be taken apart really, it's like riveted together. So I'll just spray a bit of contact cleaner into it. I mean, I could unsolder it all and take this bit out from the bottom, but I don't really want to. Hopefully that'll be enough. I'll just let that dry out. Right, while that's drying, there's another thing missing from this machine, is there should be a light here for the record, but it's been taken out and disconnected. I don't know whether it's been used in that other one. It's originally an incandescent bulb, but I'm just going to replace it with a red LED. It's 12 volts, the thing, and there's a 270 ohm resistor in series with it. Like these red LEDs, I think it's about 2 volts voltage drop on them. Want about 20 milliamps going through it. The 12 volts minus 2 is 10. That's 10 volts. So to get 20 milliamps you want about 500 ohms. There's already that 270 ohm. So if I put a 220 ohm one in series, then that should be about right. That's got a decent band. Yeah, that looks alright. I'm just going to use electrical tape. Right, I think that's pretty much it now for this machine. I'll just put it back together and I'll do a test recording on it, see how it records, make sure that's alright. Let's look at that. Someone soldered a wire across the blown fuse. Not even 8 screws then. Well, that's what's there, so I'll have to do. Right, I think I've got to the bottom of why that servo keeps going a bit mad and you're getting all them weird pulses. This chip that does the amplifying of the Capstone pulse and the inversion of this motor control pulse, it's got 2 unused gates, this one and this one, and according to this schematic they're both just tied off to earth, but on the board they're actually not. This one is, but this one isn't. And I noticed this, I spotted that I was looking at another machine and I noticed that on this one there's a jumper wire going, and it goes to this play 12 volts in, which seems a bit strange, but like if I show you the layout picture of the board, so this is the layout image, and this is a chip here. You see these 3 and these 2, they're all connected together on this one big bit that's connected to just all the big ground fill. There's a little arrow here saying like J6 jumper, yeah, which seems to be like the pointing to the output of that, but I'm not sure. But it's not actually like this. This big fill, it isn't there on the board. I'll show you actual board. This is the actual board. I don't know how well you can see, but this is like that big ground port, and it comes up here and it's connected to them, but there's actually a gap here, so it don't go to these. And I've soldered this jumper wiring and just copied what it does on that other one. And this one, there's a trace coming down here to this, which then connects to that, I think, yeah, and goes, and there's this diode and stuff. So this other gate must be doing something, presumably, on this version of board that's not documented in that service manual, but I don't know what it's doing, so I've just copied how it is on that other board, just connected it up to that. So whether that's right, it's working though. Since I've done that, it's not done that. That servo ain't gone mad. Because what were happening before, because these are CMOS chips, you can't leave the inputs just unconnected, because they start oscillating, and that's what happened. I mean, that might have been what killed that other one, because they can just get too hot. So, but that's that problem solved anyway. Right, I'll do a little test recording. It's got two different tones, so you can sort of talk frequency response thing. Like you can test it and you should get, should be both at the same level. Like, I'm not going to bother doing that, but you should be able to tell more or less. If higher one's very quiet, then you know there's a problem. That's a bit tracking. Yeah, a slight amount of flutter, like Capstone. It's not too bad. Like the red on here seems to be breaking up slightly. You can see it a little bit. So I'm not sure. I might have to record a colour bar signal, see what that looks like. Well, I'll record this colour bar signal now. Play that back. I actually just played back that test card again and it looked alright. So I put it into click position at tracking, which is like the setting that's sort of calibrated for playing its own recordings back, and it looked alright. So I think it might have just been that I had tracking in wrong position. But I'll see how this plays back anyway. Play that back. Yeah, it looks alright, it's not breaking up. This is me playing with tracking this, it's not Servo, being funny. Yeah, that looks alright. Pretty happy with that.